Hey everyone, welcome to another video for Algebra 2. We are here today to do graphing key features from factored form, page 5, lesson 1.03. Take 30 seconds to pause this video and write this down so your notebook looks like mine. So when we do notebook checks, I know exactly what I'm looking for on your page and you can get a 5 out of 5 for a little mini quiz. So we're going to do graphing key features from factored form. We're not actually going to graph until we get to class. We're going to do that together. I'm just going to do the actual notes part of this with you guys here, so it should not take very long. So we're going to write some notes down. And we're just going to write what factored form looks like and then the different parts of it. Factored form. And quadratic functions can be written in 3 different forms. We have standard form, factored form, and vertex form. We're going to start here with factored form. We looked at standard form when we did factoring. So we went from standard form to factored form when we factor. And then vertex form is something we'll go a lot more in depth with in 2 weeks. Not next week, but the week after. So factored form is y equals, or we write f of x sometimes, and it's a times x minus r1 times x minus r2. So you guys are really familiar with converting from standard form to factored form when you're asked to factor, that's what you're doing. And this is what it looks like in a general sense. So each one of these variables represents a different thing. So obviously the x and y variables represent your input and your output. So this is our output. X would be our input. And then we have R1 and R2, which is a little bit weird, or R sub 1 and R sub 2. These R sub 1 and R sub 2 values could be 2 different numbers, or they could be the same number, depending on the actual function. So these represent the actual roots. So R sub 1 and R sub 2 are the roots. Or we call them x-intercepts, or we call them solutions, or we call them zeros. So they have multiple different names. And we get these roots by taking the binomial x minus r1 or x minus r2 and then setting them equal to 0 and solving. And that's where we get r1 and r2 from. So it's really important to note too, this a value. We'll do. This a value represents something about the function, or it reveals something about the function, which is its direction. And we'll talk more about that in class. So this a value reveals the direction. So from factored form, we're able to find things that are revealed to us easily from the beginning. So it reveals the direction and the roots. It's important to know what things equate, what is revealed to us from different equations, because then it helps us graph and find key features more efficiently. So if these are things that are revealed to us, things that we would need to find would be a y-intercept by setting x equal to 0. We would need to find the axis of symmetry, which we get from adding the roots and dividing by 2. And the vertex, which we get from substituting the axis of symmetry into the equation and solving. So in this form, we have revealed to us the direction and the roots, and the things we would need to find in order to be able to successfully graph are the y-intercept, axis of symmetry, and vertex. And those are different key features. Sometimes we won't always be able to find all the key features, but we should be able to find most of the key features when we're graphing. So it's not essential to find all, but most. So just to give you guys a nice little example, of what factored form looks like, it could be something like this. Y equals x plus 2 times x minus 7. And here we can see we have our values. So we have our a value, which is here. And the a value here is 1, because it's nothing really there. So I know that a is equal to 1. And then R1 and R2 require a little bit of work. Because if you notice here, I said R1 and R2 come from setting the binomial equal to 0 and solving. So in order to determine R1 and R2, we can take x plus 2 and x minus 7 and set them equal to 0. And that gives us x equals -2 and x equals +7. So looking at that, I can see basically when I solve these roots out, when I solve these binomials out to find the roots, what happened is that it actually took this value and just made it the opposite. So I know that my roots here are going to be -2 and my root here is going to be +7. So it was the opposite of whatever it was in my binomial. So if I was going to have roots, so if I was given a is equal to -2, R1 was equal to 3, and R2 was equal to 4, or -4, and I wanted to write the equation, I know that I can do y equals -2 for a. And over here I realized it was the opposite of what it was. So here it's +3, this is going to be x minus 3. And here it was -4, so this would be x plus 4. And I can just write the equation that way. So essentially I just have factored form. This is what it looks like. This is how I can find the values that are revealed to me. And then this is what it's not revealed to me and I would need to do a little bit more work to find. And then here's just a couple of examples on how to do different things with factored form. Great. I hope you guys got this down. If you didn't, feel free to rewind, pause, or do whatever you got to do to get these notes. And I will see you in class so we can discuss this more in depth.